Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Cik Sapawi. My metric number is B1123105222. Okay, today we will present about our assignment Thermodynamic and Heat Transfer. So, the title is Conduction, Graphical Analysis on Heat Transfer. Okay, so for our team members, we have 5 members for our group. First, we have Muhammad Daniel Mukis bin Zulkifli, Muhammad Ammar bin Zainal, Muhammad Aiman bin Cik Sapawi, Amir bin Azman, and lastly, we have Daniel Fitri bin Muhammad Sharunizam. So, for introduction, this study examines the thermal performance of heat sink model fabricated from alloy 6061 through steady-state terminal simulation performance using SolidWorks. Effective thermal management is a critical aspect of mechanical and electronic system where excessive heat can lead to reduced efficiency, component damage, or complete system failure. One of the most common methods of enhancing heat dissipation is the use of heat sink with extended surface or fins, which increase the area available for the heat transfer to the surrounding air. The primary objective of this study is to analyze how varying design parameters such as fin length, surface area, as well as different heat flux levels affect the overall temperature distribution and heat dissipation efficiency of the heat sink. ROI 6061 was chosen for its favorable thermal conductivity and structural properties, making it a widely used material in cooling system. By utilizing SolidWorks for thermal simulation, we were able to visualize and quantify the effect of each variable on the thermal performance. This comprehensive approach not only enhances our understanding of the key principles behind conduction heat transfer, but also provides practical insight for designing more efficient and reliable heat sink system in real-world application.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Daniel Fitri bin Muhammad Sharunizam. So today I would like to present about the design. Alright. So there were two design that we designed in the SolidWorks. So this is the two design. So first of all, we go to the first design. So I created a straight fin heatsink using SolidWorks. I started by sketching and extruding a rectangular base block using the extruded boss or base feature. This base represents the main body of the heatsink where the heat source is attached. Next, I designed a single straight fin on top of the top surface, also using extrusion. Then I use the linear pattern tool to replicate the fin across the body, maintaining equal spacing between each fin. I intentionally made the gaps larger between the fins to test how less dense spacing affect heat transfer. The design is simple, clean, and resemble what we often see in low to medium heat producing devices. However, because of the lower surface area, it doesn't perform as well as in terms of heat dissipation. So, I will be showing you about the isometric of the first design. So, this is the isometric of the first design. And then we go to the second design. Alright. So, as for the second design, I wanted to improve the performance by increasing the surface area, so I created a zigzag fin heatsink pattern. I started the same way with the base block, and then on the top surface, I sketched a zigzag fin profile using angled line to perform the wave-like shape. Once the sketch was done, I extruded the zigzag shape upward to create the first fin. After that, I used linear pattern tools again to duplicate the zigzag fin across the heatsink. And this time, the gaps between fins are smaller, creating creating more fin density and increasing the overall surface area for heat transfer. This type of design allows for better airflow disturbance and more contact between the metal and air, which helps cools down the component faster. So let's see the isometric for second design. So this is the isometric for second design. As you can see, the zigzag pattern that I said earlier. So next, a quick comparison of the design to compare both design one, which is using vertical fins with wider gaps. It is easy to manufacture but offer less surface area. As for the design, as for the second design, we uses zigzag fins with tighter spacing. It provide a higher surface area and better cooling performance. Both were made in SolidWorks features like extrude, boss, or base, sketch, and linear pattern, and both use alloy 6061, which is great for thermal application.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad bin Zainal, and my part is to explain the simulation for this assignment. First thing first, the goal of this simulation is to evaluate and compare the thermal performance of two heat sink designs under the same boundary. Both models are subjected to steady state thermal analysis and understand their heat dissipation capability. So for the first step is we set the heat power for 65 watt. Next, we set the heat flux to 1500. We set that at the top of the model. Next, we set the convection coefficient to 5.03 and the ambient temperature to 303.15 and select it to all boundaries at the model. After that, we mesh the model, and before we run the simulation, we must to select the material for this model. We use alloy material, and we are ready to run this simulation. So this is the output after we run the simulation at this SolidWorks. So this is the output after we run the simulation at the design one. As we can see, at the hot side, its average is 97.3 degrees, and the cool side average is 79.5 degree. And as we can see at the design 2, after we run the simulation, the hot side average is still 97.3 degrees, but the cool side average is 72.00 degrees.
So next, we will go to my part, which is discussion. So for this discussion, I make in table to ease the understanding about our design. So as we know, we have two design, which is design one and design two. That also known as a heatsink. So what is actually heatsink? Heatsink is a device that dissipate heat generated by electronic component to prevent from the overheating. So for both design or overheating, we using the same material, which is alloy 6061. So actually, this alloy are combination between three main material, which is aluminium, magnesium, and silicon. This why the reason commonly in industry they use this kind of alloy to make the heat sink because it is a good mechanical properties, weldability, and corrosion resistant. It also a heat treatable alloy, meaning that it can harden through heat treatment and is often to use in structural application. So next we go for the surface area. So for both design, we design a different surface area, which is for design one, we design as a straight fin design, while for design two, we design a zigzag fin. So after simulate, we can conclude that for the straight fin, it allow less heat to dissipate through the surface area, while for the zigzag fin, it allow more heat to dissipate through the surface area. It is because the performance of heat sink is influenced by air velocity, material selection, protrusion design, and surface treatment, and also the surface area itself. So as we can see, actually, the zigzag fin has a larger surface area rather than the straight fin. That's why the zigzag fin allow more heat to dissipate, which is it can get cool more rather than the straight fin design. So next, for the design A gap, for the design one, the gap each fin is larger, but for design two, the gap each fin is smaller. But the smaller of each gap, that means the more gap that we have at the design. While for the design one, we have a large gap, but we have the less number of gap. You need to remember that we have a large gap, but the number of gap is less. While for design two, we have a small gap, but we have a more number of air gap. Air gap actually is very important because it allow a better air circulation and increase the efficiency of heat transfer and convection. Because convection occur between cool side of the fin surface and the heat surrounding air. So from here, actually, from both design, after we simulate, we discuss among the team members, we can conclude or we can summarize actually the best design that we make actually is design two. Because what? Because it allow more heat to dissipate through surface area, and at the same time it has more air gap for the heat transfer occur. Uh, in the simulation itself, we can see the design two cool more faster rather than design one. So I think that's all for discussion part. We go for the conclusion part.
My name is Amir bin Osman. Today I want to present my part is conclusion. Okay. Throughout this project, we have learned how to create and analyze thermal design using SolidWorks, a powerful tool for 3D modeling and engineering simulation. Our study focused on heat transfer using fin, and we discovered that several key factors influence the efficiency of heat dissipation, including the fin's length, surface area, shape, volume, and the thermal conductivity of the material used. We also observed that the number of fins plays a critical role, as increasing the number of fins can enhance the rate of heat transfer by providing more surface area for thermal exchange. By comparing different designs, we found that design 2 offered with superior performance in conduction heat transfer. This is primarily due to its large total surface area and more strategically placed air gaps, which improve airflow and heat dissipation compared to design 1. Overall, our, our findings highlight the importance of thoughtful design in thermal management system and demonstrate how simulation tools like SolidWorks can be used effectively to optimize engineering solution. Okay, thank you.